Hey guys, my name is Frank and this is the Python programming video log. Today I'm going to show you how to make a 2D polygon class using pure JavaScript. By the end of this video you'll be able to make what you see on the screen, so stay tuned to see how it's done. In this video I'm going to show you some fundamental methods that will definitely come in handy for building a polygon class. First, I'll show you the constructor so you can get a feel for what we're working with. Then I'll show you how to move, rotate, and scale the polygon with some easy functions, and of course, we'll take a look at how to draw a polygon to a canvas element. Be sure to check out this source code and the working example for yourself after the video so you can see how everything works firsthand. I've got those links in the description of the video below. Anyway, let's get to it. Alright, so this here is the Polygon 2D class. It's going to be the class to govern our polygon, obviously, and also we have the Point 2D class. That's going to keep track of each point in our polygon. So the Point 2D class is just an X and Y coordinate. That's all it is. And the Polygon 2D class has a bunch of those points, the vertices, and it also has a registration point. The registration point, or the position, is just going to be, for this polygon, it's going to be the center point. But it doesn't necessarily have to be a center point. It could be any location relative to the points. It's just going to be what we move our polygon by, what we rotate our points around, and our origin for scaling, basically. It's just a registration points. If you look at stuff like Unity, all of their objects have a registration point. It's kind of the same kind of deal. So it's a registration point. Rotation, that's just going to be the rotation of our polygon. Starts at 0, goes all the way to 360, or 0 radians all the way to 2 pi radians. That just keeps track of what direction our polygon is currently facing. Same kind of idea for scale. We keep track of the scale. When we start out our polygon, we first initialize it. We're going to have a scale of 1. This one started out with a scale of 1, and I scaled it up to 40. So it's 40 times its original size. And we'll take a look at the constructor so we can see what I'm talking about original size there. Anyway, this is the vertices array. So this, I know we have this defined up here, but this is actually going to be a vertices array of point 2D objects, whereas this, what we hand into the constructor, is just going to be actual just raw numbers for each coordinate. So each XY coordinate is just going to go down the line XY, XY, XY for each point, and we're going to hand that in. And we're going to set this vertices array up here, the this dot vertices array, equal to a bunch of points that we create in this for loop to match each one of the values in this array. So let's go ahead and take a look at the constructor down here. So here we're constructing a new Polygon 2D object, which is going to be this guy. So we hand in the registration point. When we start it out, it's going to be all the way up here at 0, 0, but later on in the code, in fact all the way down here in resize, every time the screen resizes we set the polygon's position equal to the center of our canvas. So the canvas width times 0.5 and the canvas height times 0.5 is going to be the center of our screen. So that's why it's in the center of the screen and not starting out at 0, 0. And let's go back up here. Then we have our vertices just in raw coordinate format. We don't have any individual points, but we could easily enclose this and say like new point 2D and hand in these values and just hand in the actual array of points from the constructor. But I think that is kind of sloppy. I don't like the way that looks, so I just hand in the raw point values right here for each point. So this would be a point on the polygon, this would be a point on the polygon, this would be in all the way down the line, and then when we are in the constructor actually takes care of sorting that out with this right here, and it creates a new point 2D object from each set of those points that we hand into this vertices argument array in the constructor of the Polygon 2D class. So how do we move a polygon? Because it has all these points in it, so we not only have to move the registration point, but we have to move all these additional points as well. It's not that difficult really. Here's the function for it, set position. It's basically going to take a destination, a desired location to move it to, and it's going to get the distance between the current location, the current position, and the desired position, and it's just going to move every point and the registration point by that distance amount between the desired location and the current location. So to illustrate this, let's say we're going to move from the center of our polygon out to where the mouse is. Now let's say the center of the polygon is at on an x-axis, it's at 500, and we want to move it to 600. Well, we take the desired location, 600, and we subtract the current location, which is 500, from it, and we get 100. So we're going to add vector x to each vertex in the polygon and to its registration point, and that's going to say its current location plus 100 gives us 600. So that's how we do it. We just get the distance between the desired location and the current location, and we then go through, we loop through each vertex or each point in the polygon, we add that amount to it, and finally we have to remember to add that to the registration point as well. So now let's see this function in action so you can kind of understand how it's working. I'm going to go down to the game loop. If I can find it here, the game loop right here. And I'm just going to come in, I'm going to say polygon.set position, polygon.position.x plus 1, because we want to move it to the right 1 on each frame, and then we're going to do polygon.position.y. We're just going to move it to the right. So let's see what happens. And it's moving to the right plus 1 on each frame. Let's go ahead and move it to the left. We're going to say -1. We're going to save. We're going to refresh. Now it's moving to the left. All right, great. So now let's just not move it at all and talk about why this works the way it works. So set position is taking the destination that we want our polygon to be at. So if we don't move it from its current position, if we don't include this current position, if we just say we want it to be at 100, it's not going to move 100 pixels on each frame. It's just going to go and move one time to these coordinates, 100, 100. So you can make a function that moves it by the specified amount on each frame in a direction. Say you want to move 100 pixels to the right on each frame, like you might think this is doing. That would be a different function. This function is just for moving it to the location one time, and if you want it to update the position, you're going to have to do something like polygon.position.x plus whatever value you want to get that updated movement on every frame to get this. All right, so hopefully that clears up how you want to move a polygon. This here is the rotation function that handles rotation for our shape. So basically it takes a desired rotation value and it sets the polygon's rotation to that value. If I want it to face 0 degrees rotation, I'll throw 0 in here, it will face 0 degrees rotation. If I want it to face 90 degrees rotation, I'll throw 90 in here. Actually, I would throw the value in radians in here, so it would be pi divided by 2 for 90. But basically I'm throwing in an angle value. Either you could do degrees, but I'm currently doing radians with this. So I'm going to throw in a radian value for rotation, and it's going to face this shape in that direction. So to better explain what's happening here, I have this picture of a unit circle that I got from Wikipedia, and I'm just going to go ahead and go through and show you what's happening. So I keep track of the current rotation of the shape, and to get to the desired rotation, I'm just going to get the distance in rotation in radians between the desired rotation and the current rotation of the shape. So to put this visually to you, let's say the current rotation is 0 degrees and the desired rotation is 90 degrees. So I want to go from 0 to 90 degrees in rotation. I want my shape to face from this direction. I want it to face in this direction. So I'm going to say 90, the desired rotation, minus 0, and that's going to give me this value here, which is going to be equal to 90. Then I'm going to have to convert that from rotational coordinates, from polar coordinates to Cartesian coordinates, and that's what cosine and sine do. So unit x and unit y are going to be cosine and sine of my angle. The reason I call them unit x and unit y is because those are going to be the x and y values you see around the unit circle. So in the case of 90, unit x and y is going to be equal to 0 and 1. X is going to be 0, y is going to be 1. So now we know those values. Let's see what we actually have to do to rotate the shape, or rotate each point in the shape rather, because that's what we're going to do. We're going to rotate each point around the origin, and the origin is going to be the registration point. In this case, it's in the center. If the registration point wasn't in the center of the shape, if it was over here, this thing would be rotating around that registration point, because we're going to use that registration point to move our points back to the origin, and that's what I'm going to show you right now. So before we can rotate, we have to move our points back to the origin. Now 0, 0 in the world is right here. That's the origin of our world. The origin of our rotation for our polygon is the registration point. So if we really want to rotate our points, we have to rotate around 0, 0 because that's just how the numbers work. So in order to do that, we have to subtract the distance between the actual origin of our world and the registration point of our shape, and we have to move all our points back to the origin by that distance. So that's what happens right here. We have vector x and vector y, and we're just taking the x and y coordinate of any given point, and we're subtracting the registration point or the center point from it, and basically it's going to move this polygon right back to 0, 0 in the world. So the center point of the polygon will be moved here after this code here runs on it. Then we're going to actually do our rotation, because we can do the rotation once we're translated back to our origin in our world. So the first thing we're going to do is we're going to take vector x, which is the distance between the origin and our point, our given point, which could be any of these points. We're going to loop through all of them and run the same code. So let's just take any random point. Vector x and y is going to be the vector between the origin and our point. We're going to multiply it by unit x, and let's actually take a look at the unit circle and work this out mathematically as we go. So let's say our point is someplace out here. So vector x and y is going to be the vector between the center point or the origin to that point on the polygon. So let's say the point is right here where this arrow is. The exact value of x doesn't matter, but we know that the y value is going to be 0 because it says so right here, and because we're at 0 on the y-axis, which is right here. We're at 0. So the x value doesn't really matter. We just know it's greater than 1 out there somewhere, and y is equal to 0. So we have greater than 1 and y is equal to 0. We're going to set the x and y coordinate of our point. So the first thing we do is we multiply the x vector, the vector x of our point, by the unit x value. Unit x is going to be 0. So we're going to take that x value and multiply it by 0 to rotate from here to over here. So already we could see where we're going with this. Unit x is 0, vector x is any number greater than 1. It's going to be 0. So that's 0. Then we're going to subtract vector y, which also happens to be 0, multiplied by unit y, which is 1, but it doesn't matter because 0 times 1 is 0. So we're going to have 0 minus 0. So vector x, or not vector, but vertex x of the rotated point is going to be 0, which is where we want it to be for this rotation here. Now before I talk about what this is doing, let's just go to the next step. So we know that our rotated vertex is going to have an x value that is right here, which makes sense because we're rotating it from here to here, so x is going to be right there. Next we set up y, so we do vector x, which is some value greater than 1, times unit y. Unit y is 1. So we know that something greater than 1 times 1 is going to be something greater than 1. So we have an actual value for the y vertex. Then we add vector y, which is going to be 0, multiplied by unit x. Unit x is 0. So we're basically adding 0. So we have something greater than 1 and 0. And since in JavaScript, the y-axis is inverted, this is going to give us a value down here actually, but in JavaScript it's inverted, so we'd actually be moving up here, which is where we're trying to rotate to, from here to here. So our x vertex is going to be here, our y vertex is going to be up here somewhere greater than 1. So we have rotated from over here up to here where we want to. We rotate a full 90 degrees using this math right here. Hopefully I explained it well to you. Now the last thing we do is we translate back from the origin of our world. So remember I was talking about the origin of the world being here. This code right here translates our point all the way back to the origin, and then we have to translate back after we do the rotation. So we just add the registration point back. We just add that back and we translate back to the original position. So first thing we do, we translate to the origin. Next thing we do, we run this rotation code, and finally we move it back to where it was, and that's rotation for you. And the last thing we do in this function is we set the current rotation equal to the desired rotation. This way the next time we call this, we have an updated rotation value. So this is the function that scales the polygon. So basically I'm going to throw in a value that I want to scale to, and it's going to scale to that value. If I want to scale to 40 pixels like I did right here, it's going to scale me up to 40 pixels. If I want to scale back to 1, I just throw a 1 in there. It's going to scale me back to the original size. So let's take a look at the actual original size of this polygon and where I use the set scale method to scale it to its ratio of 40 to 1. So right here is the original polygon. Here's the center point or the registration point, and here are the points around it. As you can see, the points are initially very close to the registration point of the polygon, but I then go ahead and scale it up to a ratio of 40 to 1. Let's comment that out and see the actual size with a scale of 1 of our polygon. It is super tiny. So I don't want it to be super tiny, but I think it's cleaner to have this nice, almost unit-sized layout of our polygon, or size of our polygon. I like that for a scale of 1. And then I just scale up to 40, and this is real easy to read. I can tell where these points are in relation to the origin. If I were to put 40 in here, negative 40 and negative 40, it starts to get harder to read. The more polygons you define, you have all kinds of different shapes and sizes. I just like to keep it on a small scale, so that's why I do it this way. You don't have to, however, obviously. So let's go ahead and put it back to regular size by commenting this line back in, and take a look at the actual scale function here. So the first thing we're going to have to do is get the ratio to scale by, because we want to keep track of the current size of our rectangle, or not a rectangle, but our polygon. We want to keep track of the current scale of that polygon. So we have to get the ratio between the desired scale and the current scale. So initially we have a current scale of 1, and we can see that up here in the constructor. The current scale when we start out is 1, and then our desired scale is going to be 40 down here. When we scale up to 40, a ratio of 40 to 1, we're going to have 40 to 1. So that's going to be our ratio. 40 divided by 1 is 40. So I know I have to scale this thing up by 40. Let's say that I had a current scale of 20 and I wanted to scale up to 40. Now it's going to be 40 divided by 20. I know I have to multiply by 2, or 40 divided by 20, to get to my desired scale. So this is a cool way of doing it, because you keep track of the scale, and if you ever want to scale back down to a scale of 1, a ratio of 1 to 1, you just have to throw 1 in here and it scales you back down to 1. So that's why this is a good way to do it. Next, let's talk about the actual math and logic that goes into scaling this thing. So we're going to loop through every point, just like the other formulas, the other functions for rotation and movement. We're going to loop through every point because we have to run an operation on each point or vertex in our polygon. So the first thing we do is we get the vertex we want to use. It could be any one of these. It's going to loop through all of them. So let's take a given vertex. The vector is going to be equal to the distance between the vertex and the origin. So the first thing I'm going to do is I'm going to translate the vertex back to the origin. And I'm going to store the distance between the origin and the vertex in vector x and y. So we're moving the points from the local origin around the registration point, or the center point of the rectangle, and we're moving them all the way back here to an origin of 0. So the center point is now going to be up here at 0, 0 in our world, and that's where we're going to start from, and then we can go ahead and do the scale. So vertex x, we're going to set equal to vector x multiplied by the ratio. That's going to give us our scale. So let's say the distance between our center point or our origin and our vertex on the x-axis is just 1. That's going to be 1 multiplied by 40, and that's going to give us 40, and that's what we want. Now, if we didn't translate back to 0, 0, our vector x would be very different. We would be scaling up the distance between 0, 0 and one of these points, and that would give us a huge blown up out of proportion thing. So we have to translate back in order to get an accurate scale. So we're basically just going to translate back, get the distance between the origin of 0, 0 and whatever value our vertex has, the x and y values of our vertex. We're going to multiply it by the scale ratio, and then we're going to translate it back to its physical location in the world by adding back the registration points x and y values. Then finally we just set scale, the current scale, equal to the desired scale, and we're ready to go ahead and scale again. So that's how the scaling works for this example. Here's the function I use to draw the polygon. It takes two arguments, the polygon object to draw and the color to fill it with. Now you could just as easily substitute stroke for fill. I just like filling in the polygon. You could use stroke to draw a solid line around the border of the polygon. That's pretty cool too. Or you could use a combination of both, whichever. But basically what you want to do is you want to make a path that connects all of these points, and then you want to draw that path or fill that path. So here's how we do it. We start out, we just get the first point in our vertices array. So this is going to be the point or the vertex at position 0 in the vertices array. Then we're going to begin a path. Then we're going to move to on the context. So basically the pen of our context or the drawing utility of our context, we're going to move it to the start point that we got here at our first vertex, at x and y, that first vertex. Then we're going to loop through the rest of the points back to that first vertex. We're going to set index equal to the last vertex in the vertices array of the polygon, and we're going to go down until we reach this first one. So let's say the first point in our polygon, or the first vertex in our polygon, is this right here, and it goes all the way to the last point. We're going to start here with move to, and then we're going to start drawing with line 2, starting with this one all the way back around. So we're starting here, we're going to use line 2 to go here, 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 and then finally back to here. So that's what we're doing. We're just looping through. We're using move 2 to start our path. We're using line 2 to complete our path back to the end. And then finally we're saying context.fillStyle equals the color, and we're going to use context.fill to fill that polygon in. And that is the way I use to draw my polygons. If you learned something from this video, go ahead and give it a like, and why not subscribe for more videos. I've got links to the working examples in the description of every video, as well as the full source code for your viewing pleasures, so go ahead and check that stuff out, and be sure to check in next time for another useful video. If you have anything you'd like to say, please leave a comment. Sharing links to personal projects is always welcome, as is constructive discussion. Anyway, thanks for watching. I'll see you next time.